Ignition sequence starts.
Good morning. This is the view inside the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. A team of specialists is on duty here around the clock to monitor station systems and assist the expedition crew members on board with their work, as has been the case for nearly 20 years straight. Sergei Ryzhikov, Kate Rubins, and Sergei Kudzverchkov now have their turn in a line that stretches back to when Bill Shepard, Sergei Krikalev, and Yuri Gudzenko launched 20 years ago and began 2 decades of uninterrupted human presence in space.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Sandra Jones. This week we celebrate the 20th anniversary of the Expedition 1 launch. All the while, the science continues on this space station as we learn about how the microgravity environment of this space station affects the human body. On October 31st, 2000, NASA astronaut and commander of the Expedition 1 crew, William Shepard, and his Russian crewmates, Sergei Krikalev and Yuri Gudzenko, launched to the International Space Station, officially beginning the continuous presence of humans living off the planet. Shepard reflected about his historic mission with NASA's Gary Jordan on the latest edition of Houston, We Have a Podcast.
If we're going to go past the moon, out to Mars and maybe other places, asteroids and things like that, the character of how we will do this is going to have several aspects. And they're going to have to combine the resources of more than just one country, because the expense of a Mars mission is not something any single country is going to be able to afford, nor would they have all the technology and capability that will be required. And so if you look at International Space Station, it's really a blueprint for how to do this.
You can hear the entire interview with Commander Shepard right now or anytime. Houston, We Have a Podcast is available on Apple Podcasts, Google Podcasts, SoundCloud, or nasa.gov/podcast. In the 20 years that have followed, 241 people from 19 countries have lived and worked aboard the International Space Station, completing almost 3,000 science experiments. And that science continues. NASA astronaut Kate Rubins took part in a study to determine to what extent an astronaut's ability to visually interpret motion, orientation, and distance may be disrupted in a microgravity environment, and how it may be changed upon return to Earth, as part of the effect of long-duration hypogravity on the perception of self-motion study. Back on Earth, NASA's SpaceX Crew 1 mission has a new target launch date. NASA astronauts Michael Hopkins, Victor Glover, and Shannon Walker, along with Japanese Aerospace Exploration Agency mission specialist Soichi Noguchi, are now scheduled to launch at 7:49 p.m. Eastern Time on Saturday, November 14th from Launch Complex 39A at Kennedy. NASA will provide continuous coverage until they are welcomed aboard the International Space Station as Expedition 64 crewmates, where they will spend 6 months conducting research, maintenance, and spacewalks. Visit nasa.gov/commercial crew for the latest information on Crew 1. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
We are just days from the 20th anniversary of the arrival of Expedition 1 at the International Space Station, which began a human presence on the space station that's been uninterrupted right up to now. In that time, 241 different people from 19 countries have floated aboard and taken part in nearly 3,000 scientific investigations while getting humanity ready for future exploration out into the solar system.
This was once just a dream.
TTC go. TTC is go for launch.
2. Which to the mission and liftoff of Discovery and a team of explorers shaping their destiny.
An answer built by those who dared to ask, what if we were to channel humanity's knowledge and creativity into something truly revolutionary? What if we built a bridge between and above all nations? to jointly discover the galaxy's great unknowns, to endeavor to live and to work outside our planet for the benefit of all within. What started as an accord between two former rivals became a beacon of opportunity for the rest of the world.
We have ignition and liftoff of the Soyuz rocket, beginning the first expedition to the International Space Station and setting the stage for permanent human presence in space.
You ready for visitors?
We live this dream aboard the International Space Station.
I understand it's good to have you there and adjusting to your new home.
Adapting to life in space. It's been a process.
For the past 20 years, over 230 astronauts from all over the world have worked tirelessly together, boldly performing pioneering research and high-stakes spacewalks in the unforgiving environment of space. In this unparalleled orbital laboratory, circling the planet at 17,500 miles an hour, thousands of groundbreaking scientific experiments from over 100 countries have led to discoveries unachievable in the confines of Earth. From 250 miles up, an unbroken chain of residents have shared their view and their research with a generation eager to understand this higher plane. The space station is a symbol of humanity at its best, a shining example of international peace and collaboration in action.
3, 2, 1.
Endeavour, this is Houston. You've completed a historic ride to the ISS and have opened up a new chapter in human space exploration.
And as we turn our gaze outward still, this International Space Station is a living testament of our collective strength and perseverance, where our human curiosity prepares for the audacious efforts ahead. We continue to bridge the distances between us and prove just how much more is possible when we dream together.
All of the International Space Station crew members have had their part in the station's science mission. NASA astronaut Christina Cook spent 328 days on board doing science, and just before she came home early this year, she talked about some of the research highlights, which give a sense of the breadth of the station's science mission.
First and foremost, our responsibility is to our crew up here to keep each other safe. Secondly, I would say our responsibilities are the work, the amazing work that we do as part of this orbiting laboratory. As a microgravity laboratory, we do science in all kinds of different arenas, from physical science to biological science, human research, technology demonstrations, and many more. So doing that work and carrying out the work that is the purpose of the International Space Station is definitely one of our responsibilities. And I also think that we have a responsibility to the people that we represent up here, to carry people's dreams into space with us, to communicate the perspective that we have up here.
Okay, copy that. I'll step through on my own for the setup and let you know when questions come up. And yes, we definitely are all doing this as a we and as a team. So you all will be installing the test cartridge as well.
We have a series of tasks that we're asked to do, and we know that it's going towards a good cause, that it's benefiting the Earth, and that it's advancing the cause of exploration for all humanity. So being able to participate in that every single day is such an honor, and I'll definitely miss that. The microgravity environment is a lot of fun. It brings about a lot of interesting changes in the human body, and obviously it enables the amazing science that we do here. When I think back about the legacy of this mission, I think the thing that I'll be most proud of is just bringing my best every day and contributing and giving back to this program that has allowed me to be here, has allowed me to work for, a mission that I've believed in for my whole life, to my training teams, to the teams on the ground, the engineers, the planners, and the flight controllers that make everything possible. And like I said, just remaining vigilant in meeting the challenges every day up here, and just remembering that it's all about giving back and contributing.
While the International Space Station is often a platform for science about the Earth, it also hosts science and technology research that's benefiting life on the Earth, while supporting plans for future exploration far, far away from Earth. Those future deep space missions that will carry human explorers will have to support those people with, among other things, clean water. Station research in that area has had achievements that are already paying off on orbit, and led to an inexpensive, easy-to-use tool that allows people on the planet to check the purity of their water.
Most of the children, they come here with waterborne disease.
So many children under 5 suffer from diarrheas.
They're complaining about the abdominal pain, skin rashes.
They get waterborne illness through drinking waters.
Most of the community members had little knowledge regarding the use of safe water and what safe water is.
Because most of the water we use it without knowing it is affected with disease or not.
So we need to test them so that we make sure that the water is safe or not safe.
A lot of people have the idea that water quality is too hard to do in the field and it's too complicated.
Having to transport samples, having to have reliable electricity, having to heat samples or keep samples at certain temperatures or put them in refrigerators.
But probably the biggest challenge is actually the cost.
The price was really high, up to $300 a test.
So all those things come together to make it really difficult to use a traditional laboratory approach when you're testing water. What's been missing is the really simple, cheap test kit, and that solution came from above. On the space station, we recycle almost all the water that the astronauts drink, and that constitutes a risk because if that water became contaminated, the astronauts would have to abandon the space station in the worst-case scenario. What we needed on the space station was something that was small, easy to transport, and didn't require a lot of training for the astronauts. We developed a water test kit that was really easy to use and used off-the-shelf components, and we called that the Microbial Water Analysis Kit, or MWAC. It's basically a bag that changes color in it, and the astronauts just had to hook it up to the water system, take the sample, store it overnight, and read it the next day. It worked great, and it's still in use today. This was when we realized we had a chance to make a difference in the world using the same technology that was used by NASA, but applied in a remote area of a developing country.
We started MWater for the biggest health crisis on the planet, which is a lack of safe water. The test kit is revolutionary because of its cost. It lowers the cost of testing water points from hundreds of dollars to about $5 to $7. It can be done on site in the remote region, and it can give you a result within 24 hours.
I take a sample today, tomorrow I have results. To use a MWater kit is very easier.
But we learned that testing water by itself wasn't enough. With the mobile app, people could map water sources and record the data.
So that way we're building sort of a global database of water information that everybody can contribute to and share with others.
So what that meant was people who before didn't have a feasible and affordable way to test water suddenly had the means to know which water sources around them were safe.
It's made people much more aware of the issues of water quality. That's a very powerful thing.
And that's all due to technology that we've borrowed from the International Space Station. So now we're able to assemble a really low-cost water quality test kit to ship all over the world.
We've been working with the local health ministry and the water utility in Mwanza, Tanzania since 2013.
Through that technology, most of the citizens in Mwanza have an increased awareness regarding the kind of water they use and whether it causes them any waterborne illnesses or not.
People are now treating their water and avoiding sources of water which could be contaminated. I've seen a growing awareness.
It is very unusual for technology that is used in international space stations to be used in developing countries like Tanzania, but it can be used, and it should be used because this technology is not limited to only developed countries, but for all humankind.
Along with hands-on work with science experiments and spacewalks and visiting vehicles, International Space Station crew members use some of their time for educational events in which they talk about science with students on Earth, discussing their mission and sharing the value of learning about science, technology, engineering, and math. In this demonstration video, Randy Bresnik demonstrates Newton's second law of motion.
Hello everyone, I'm astronaut Randy Bresnik, living and working aboard the International Space Station. Now, on the space station, we live in a microgravity environment. Do you think the laws of physics will hold up? Come on, let's go find out.
The acceleration of an object depends on the net force acting on the object and the mass of the object, or F equals ma.
Surely good show, Sir Isaac.
Here we see that once the force of the thrust is greater than the weight of the vehicle, the rocket begins to accelerate.
All right, we're going to start with something small, something you might have at home, a little stick of chapstick. We'll go ahead and use our force, being our bungee cord here. We'll put it on our bungee, and we'll pull it back. Let it go. And you can see how fast it accelerates because there's very little mass. Next, we'll try a little spaceship. A little more massive, and you can feel that because as you move it, you can feel that the kind of the force, the extra force you have to push with your hand. So we'll put our spaceship on our launcher here, same spot. Notice it's flying a lot slower than that chapstick did. What we've seen is the same amount of force on a smaller, less massive object means the acceleration is faster. Well, this is the biggest and most massive thing we have, so let's see how the acceleration is affected. Pull back the same amount on the force, and here we go. And there you have it, Newton's second law of motion in action. Thanks everybody for exploring a little physics with me today. Now I'm going to send it back to Earth so you can start your experiments. See you again real soon.
By virtue of being 250 miles above the Earth and orbiting over different parts of the planet every day, the International Space Station provides a handy spot to gather data for experiments that are designed to learn about the home planet of their own creators. Here's a look at a number of those experiments, including the ones that have astronauts with cameras in their hands.
Earth's climate is the product of many rich and complex systems. It's affected by water in its many forms, on land, in the air, in the oceans, and as ice. It feels influences from vegetation, from soil conditions, from the carbon cycle, from human impacts. We study and observe our planet's ever-changing conditions in many ways, from many locations. One location in particular provides a unique and powerful vantage point, allowing us to see our planet in high detail and on a broad scale: space. The International Space Station is home to many instruments that help with the study of our planet in a variety of ways. Each is an amazing resource for scientists and researchers, but together, they paint a picture of Earth richer and more detailed than any one instrument could provide. From the vantage point of the orbiting laboratory, JEDI measures Earth's surface vegetation, producing 3D views of forest height and structure and the surface topography beneath. Forests and other plant life respond to a variety of environmental stresses. And the EcoStress instrument allows researchers to study plant temperature and provides insights into how life on Earth responds to changes in water availability. OCO3 measures atmospheric CO2 with high accuracy, helping researchers better understand CO2 increases and decreases and the impacts of those changes. And through the use of two cutting-edge spectral imagers on the station, HISWI and DESIS, researchers have access to highly detailed information on materials across Earth's surface, from identifying minerals and rock types to distinguishing between plant species. There's another and often overlooked observational instrument on board the space station: crew members equipped with digital cameras. Over 3 million images have been collected by astronauts from the station, and those images can be put to a variety of uses. William Stefanov is branch chief for the Exploration Science Office, a part of the Exploration Integration and Science Directorate at Johnson Space Center. He says handheld cameras used by the crew act as a complement to the data gathered by the station's various instruments. And that comes down to the ability of the crew to take pictures that are panoramic and oblique versus a straight-down look. That panoramic view can be quite useful when observing natural disasters as they occur, such as wildfires or volcanic eruptions. Stefanov explains, a camera is an excellent tool for examining the plumes created by wildfires or volcanoes, because it gives you an immediate three-dimensional picture of what the plume looks like, what its structure is, and how far it's extending. The observational instruments aboard the space station provide science capabilities that are more than the sum of their parts. These instruments, along with photography from crew members, serve to keep a multifunctional eye on the condition of our home planet. For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more eye-opening information about space exploration, visit science.nasa.gov.
You just saw a good explanation of how pictures taken by human astronauts are valuable to the science research being done on the International Space Station. But scientific observation is not the only kind of observation they engage in. NASA's Drew Morgan returned from the station earlier this year, and he says the views of Earth you can get from 250 miles up, well, he says you can't have that experience and not be changed.
I remember looking at the Earth for the first time just shortly after we had launched. We had a nighttime launch, and within 9 minutes or so, we're in orbit. And I remember seeing the Terminator, where the light meets the dark on the surface of the Earth. There's an overwhelming sense of gratitude for the experience that so few humans have had to be off the planet and look down at it, and look down and appreciate how beautiful it is and how perfect it is. We're so fortunate to live on such a perfect planet, positioned where it is in the solar system, and that we know of nothing quite like it. When you're out on a spacewalk, when you're outside, your helmet gives you essentially a 180-degree view of everything around you. In my last spacewalk in January of 2020, I was riding on the robotic arm out to the AMS work site, and we were waiting for one of those leak checks in between, and there was a period of time when there was literally nothing that we could do, and so they parked me on the arm above, about 50 yards above the ISS during a night pass, and they were like, okay, you're gonna just have to sit here for 20 minutes. Without the obstruction of the atmosphere, without light being refracted, stars are much more distinct. They don't have that twinkle anymore. Everything is very crisp, and naturally you see infinitely more stars and planets mixed in there that are sometimes hard to distinguish, but infinitely more. No atmosphere between you and it, and I was out there above the ISS, nothing between me and eternity. You can't have this experience and not be changed. It does affect you. But I think by and large is what you find that it reinforces beliefs that you already had, because that is our fundamental tendency, to look for evidence that supports what we already believe. It reinforced the importance of stewardship of our planet and carrying those responsible practices with us as we go out and explore, return to the moon, go on to Mars to understand the origins of our own planet. It was an interesting time in those final weeks before we landed in April. We were watching this global pandemic occur. The magnitude of what was occurring on the ground was starting to become more and more apparent as the weeks wore on, and we knew it was going to affect how we arrived on the Earth, and that they were going to have to take different measures, bring us home. We were asked to make a video that asked, what are your impressions of returning to the Earth during a global pandemic? And one of the things that Jessica and Chris and I did was we took some images out the window of the cupola, and I just spontaneously, while panning the camera around and taking some shots of my crewmates looking out the window, I panned along the Earth and I said,
"An Earth in crisis is still an Earth worth returning to."
Just spontaneously, I don't know what made me say it. I think it was a good reflection of how we were feeling about, our time up there. We appreciated it, and we had a new sense of the Earth below us, and saw that the entire planet was experiencing this event that in many ways unified us all, in much the same way that the International Space Station unifies us all, and that we still desired to return to our Earth and all of its greatness and all of its problems. It's still our home.
If you want another look at any of the stories we feature today, you can always find them. Go to YouTube and Facebook at those particular addresses you see on the screen. While you're there, be sure to look around, because there is lots of other cool stuff about NASA and America's human spaceflight program. Now, when you're interested in good conversation about human spaceflight, the place to go is Houston, We Have a Podcast, our weekly show where we talk to folks about their work in all aspects of space exploration. New episodes go up every Friday, and today, Gary Jordan observes the start of human presence on the International Space Station by talking to the commander of Expedition 1, Bill Shepard, on the podcast today. And coming on Monday, November 2nd, a talk with Space Station Program Manager Joel Montalbano, who has been a part of the station project from the beginning. Go to nasa.gov/podcasts for this week's episode, including the bonus episode on Monday. That's where you'll find all our previous episodes, too. In fact, the full library of all the NASA podcasts are there. You can also find them all on Apple Podcasts, Google Podcasts, and SoundCloud.